going to go over 3 different searching algorithms: linear, binary, and exponential. All 3 are used to find a specific value in a list, but they each approach the problem differently. Some are simple but slower, while others are much faster and better for large amounts of data. I'll start with linear search since it's the easiest one to understand. Imagine you have a list of numbers 12, 5, 8, 21, 30, and 17, and you're trying to find the number 21. With linear search, you just go through the list one item at a time from the beginning. So you check 12 first, but that's not right, then 5, then 8, and eventually you reach 21. That's really all linear search is. It checks each value in order until it either finds the target or reaches the end of the list. Because of how simple it is, linear search works even if the list hasn't sorted. The numbers can be completely random and it still work fine. The problem is that it can get pretty slow if the list is really big. If you had thousands or even millions of values, the algorithm might have to check almost every single one before finding the answer. So linear search is easy to use, but not always the most efficient option. Now, binary search is where things start to get much faster, but before it works, the data has to already be sorted. So imagine we have this list instead: 3, 7, 12, 18, 24, 31, 40, 45, and 52. And let's say we want to find 40. Instead of starting from the beginning, binary search immediately jumps to the middle of the list. In this case, the middle number is 24. Since 40 is greater than 24, we instantly know the answer can't be anywhere on the left side. So instead of searching the entire list, we know we throw away half of it immediately. Then we repeat the process on the remaining half. We check the middle again, decide whether the target is larger or smaller, and keep narrowing things down until we find it. A good real-life example is looking for a word in a dictionary. Nobody starts on page 1 and flips through every page one at a time. You usually open somewhere near the middle, figure out where your word comes from before or after that section, and keep narrowing it down from there. That's basically how binary search works, because it keeps cutting the search area in half. It's much faster than linear search, especially with larger datasets. The last one is exponential search. This one is a little less common, but it's really useful for very large sorted datasets, especially when you don't know the exact size of the data ahead of time. Exponential search usually starts by making really large jumps through the list. For example, imagine this list: 2, 4, 7, 10, 15, 18, 21, 27, 30, 36, and we're searching for 21. The algorithm starts near the beginning, but instead of moving one step at a time, it keeps doubling how far it jumps. So it checks one position away, then 2, then 4, then 8. The jumps get bigger really quickly, which is where the word exponential comes from. Eventually, it lands on a number that is larger than the target. For example, if it jumps to 30, it knows that 21 has to be somewhere before that point. So at that stage, it switches to binary search and searches only within that smaller section. So exponential search is kind of a combination of both ideas, first making huge jumps to narrow down the range, and then using binary search to finish things off efficiently. So all in all, each algorithm has its own strengths. Linear search is simple and works on basically any list, but it can be slow. Binary search is much faster, but only works if the data is sorted, and exponential search builds on binary search by first using large jumps to quickly figure out where the target might be. So depending on the type of data you're working with and how large it is, one search algorithm might make a lot more sense than another.